Hello everyone, my name is Mingyang Xia and you can also call me Mina. I'm a student of Dalian University of Technology in China. This paper I will presenting today is titled Advanced Design of Next Generation Glucose Biosensors. So first, I will show my context to you, and then I will give you some simple introduction about my topic. Nowadays, diabetes turned out to be a disease that threatens many people's health. In serious cases, it may lead to dangerous conditions such as brain hemorrhage and high blood pressure. Therefore, people with diabetes need to check their health condition. In 1962, Clark and Lyons first presented a paper on enzyme electrodes and introduced the concept of glucose biosensors. Since then, glucose biosensors have been studied extensively and stand out in many fields. Yet, there is still a great amount of work that needs to be done to improve glucose biosensors. So more research is required to make glucose sensors more convenient and sensitive. My paper has presented a summary and study of glucose biosensors based on previous research, and then I will describe the classification of this topic. There are many types of glucose biosensors, and in this presentation, I want to focus on two of them. First, for enzyme glucose biosensors. Enzyme glucose biosensors are the most common type of sensor, and three generations of enzyme glucose biosensors are widely known today. These three enzymatic glucose biosensors have different oxidation media. For the first generation, the most common media is oxygen, and for the second generation, sensitive receptors are used. And for the third generation, no medium is needed. And now let's turn to non-enzymatic glucose sensors. Despite the widespread usage of enzymatic glucose biosensors in daily life, non-enzymatic glucose sensors are beginning to draw greater attention as a result of the drawback of enzymes, such as their poor stability and their high cost. The non-enzymatic glucose biosensor is a very fast and inexpensive technology which depends on the direct electrochemistry of glucose. But direct glucose oxidation at precious metal electrodes is subject to some limitations. So increasing the amount of glucose to come into direct contact with the electrode may reduce the limitation in sensitivity and selectivity. Now I will show the mechanism of these two kinds of glucose biosensors. First, for enzyme glucose biosensors, GOX is the most common enzyme in glucose biosensors and the standard enzyme in biosensors. In glucose biosensors, fixed GOX catalyzes the activation of beta-D glucose via O2 molecule, leading to H2O2 generation and gluconic acid generation. The complete reaction equation will be shown as this. And in addition, flavin adenine dinucleotide FAB, which is a redox cofactor, is also required for GOX to operate as catalytic agent. FAD, the original electroreceptor, is then converted to form FADH2, as shown in the equation like this. The cofactor will be reproduced by O2, producing hydrogen peroxide. The equation is like this. And for non-enzymatic glucose sensors, it no longer requires the effect of enzyme like GOX, but rather a variety of electrocatalysis to catalyze the oxidation reaction of glucose. Researchers have studied several electrocatalytes, such as PT-based glucose biosensor. PT has a high catalytic activity and good stability, and three potential regions appear when electrochemical oxidation occurs. The three regions lead to oxidation of glucose itself rather than surface bending. And as we know, the development of any kind of technology takes a long time. So here I will give you some development notes of the glucose biosensors. The concept of glucose biosensor was first presented by Gloucose in 1962. And the first commercial glucose biosensor was used in 1975. And it was almost exclusively used in clinical trials because of its high cost. And in 1982, Shisari proposed a needle-type enzyme electrode for subcutaneous implantation, and the commercial needle glucose biosensor was then marketed by Mingyang, which is a famous American medical technology company. However, it was still not user-friendly because it didn't real-time real data, and test results were only visible in doctor's office. And nowadays, continuous glucose monitoring systems are more widely used by people with diabetes. The CGM system is a self-testing system which provides real-time data to diabetic patients throughout the day, and can provide much convenience to diabetic patients. However, it was very expensive, and the issue limits access to many people with diabetes. So it has been one of the most biggest drawbacks of this technology. Today, glucose biosensor has been developed considerably, but it still has many areas waiting for further development. So here I have some thoughts. Firstly, smaller dimensions. Nanotechnology is a technology that has been continuously researched. So with more development and advances in nanotechnology, there is an opportunity for glucose biosensors to become even more miniaturized, and they may be available for more aspects of life, such as detecting the glucose levels in food products on the market. All of these will bring even more convenience to life. Secondly, more efficient. As mentioned earlier, many types of sensors are available, and each of them is constantly being improved and developed, but they still have some limitations. As biosensing technology advances, glucose biosensors will have greater potential to achieve low cost, high sensitivity, stability, and longevity, overcoming today's problems to maximize their role and achieve the maximum efficiency. And thirdly, go wireless. The extendance of wire and power sources often limits the environment in which the sensor can be used. So if the wireless issue could be addressed, this would greatly facilitate the use of glucose biosensors. And in the future, when power sources and wiring no longer limit them, the sensors will achieve greater freedom. So in conclusion, this paper provides a concise summary of glucose biosensors. The analysis and research in this paper are only the projection and an outlook, and there may still be some problems in their implementation, and it may take a long time to develop them. However, future research should go further and attempt the many utilization, efficiency, and values mentioned above to help a wider range of people to use them. And this is my reference list. Thank you for your listening.